for soil, the moisture retention side, but there's also a biological aspect. In that the way we're curing it down, we're able to keep the microbiology alive in the product. Even though it's dried down, we're trying to get it down below 12% moisture for storage and for handling and to put it through the equipment. So they can act pretty much just like a regular fertilizer pellet. And so you don't need any specialized equipment, it can just go right in your program. So, but we're able to, and I know there's a YouTube video out there too, showing it under a microscope with it basically coming back to life once you get the moisture back into it. So that seems to be a big aspect. So, and part of what we found out through the research is the different feedstocks and the way you compost differently and set it up, you can have actually different kind of species in there. So, and there's research out there to show that there's different types of species of microbiology that help suppress soil-borne diseases like Rhizotonia and Fusarium and some other things too. So we're seeing that kind of build up in the soil, and we have, right now we have anecdotal evidence showing some Rhizotonia suppression in fields that were treated with our material last year, where everything else that was untreated was diseased, the things that were treated with our material were not. Right now it's only anecdotal because we didn't do it as specifically a setup control type of thing. So that is one thing we're going to be working on to show that. We're showing some really good things.
Too.
It's true. But we're seeing a synergy between that material and regular fertilizer. But the big thing that we're showing is typically in a compost thing, and I said before, for centuries, eons, everything was organic until post-World War II when we came out with DDT and the other things. So, but we need to we really need to come back to what tools really work. What new things have come on, the old things, but we had to come up with something for today's modern precision agriculture. And that's what we try to put together. We're seeing the synergy between even bringing down your fertilizer, but we're not saying get rid of your fertilizer. It's all about putting it together. And we're seeing yields that are better. We're showing 17-21% better yield when you're using it with your normal fertilizer program. The previous year we were doing experiments with cutting back the normal fertilizer by 50% or 30% and showing the same or better yields than if you're going full fertilizer. But the one thing is, typically when you think compost, you think manure spread. You think throwing down masses of material. What we're saying is by doing it this way in a precision application, that you can bring that down from 2 to 5 ton, which is a typical application of compost on a field. You can bring it down to 40 pounds per acre. And at 40 pounds, you're putting it in with, on the no-till or a direct seed, you can put it right along with that seed. And by being in contact with that seed, essentially, you're getting that good start, you're setting up the soil correctly, you're adding the microbes, you're adding the carbon right there at the start. And we're getting the same kind of results as if you were putting down 5 ton. And why it seems, at first it even sounded a little bit magical for how in the world can that be? But when we start breaking it down by simply looking at the densities of you're treating that seed zone, and if you think about it as a tube running through your entire field, in that small little seed zone all the way through, we're actually at a higher density with this product in that little area than if you would be treating 5 tons and working it down 3 to 4 inches through your entire soil profile.
Don't eat this.
So it's right there for when that seed sprouts and they make contact. So, but that's why it's working. It's because of the way that it's formed, it's the way that it's set up. It's about the application. It's about using today's modern equipment and not trying to just blow and go and try to get it all out there. So when we're looking at that kind of situation, and normally at 5 tons, even without the haul, without the spread and everything else, even on some really inexpensive compost, you're looking at, $20, $15 a ton per ton. Where at this, we're looking at being somewhere in that 25 cents a pound range. And then at 40 pounds, you're looking at something like $12, $15 an acre, as opposed to, that higher cost. and it's working because you're treating that seed zone and getting it out there. So we've been really surprised with the results as we're going, but we keep fine-tuning the research. So where we're at now is we've made the commitment as a company to go full blast. We're building the plant right now to be able to put this in a full commercial production. We've been using a toll processor up to this point to get things going, to have enough material to get it out there for experimentation, for trials and that sort of thing. But we made a commitment and plan to be in full production this fall. So that's where we stand right now.
What are your sources? Like what kind of sources do you use for your compost?
Well, we do a couple of different things. We bring in mint from some farms in the area, so we do a lot of mint biomass. And we compost it completely separately from everything else. But when we also do a yard waste and a food waste based compost, we do two kind of things. And we're getting that across the region of Washington State. So it's coming from multiple regions, but we just do the blend and put it all together. So we call that Royal Classic Compost, and mint we call it a supplement. The interesting part about the research we did, and something we'd never found before in the research, is that there are two different feedstocks, and we saw some really interesting dynamics in the soil. With everything else being the same fertilizer setup, the same soil type, everything else, we were seeing with these different kind of feedstocks, one was increasing the boron uptake without increasing any boron in the soil. Another one was increasing magnesium, I think it was, at a different rate than anything else. And it started clicking with different feedstocks are doing these other issues. So what Compell has turned out to be is a blend of the two on a specific ratio. So it's been engineered as the ratio that we dialed in of the two different kinds of materials to do the best in wheat. And it's also being used right now in the canola out here. So that's what we're running with at the beginning. But based on that initial knowledge, we know where we need to go in the research to fine-tune it for other crops, or to see if that's the blend for those crops. And so that's the stage we're at. So to answer your question, it's multiple kinds of different feedstocks, but actually very different types of compost we're starting off.
Do you work with any of the manures from the excess manure from dairies and stuff?
Pardon me?
Like manure from dairies?
No,
Do you guys work with any of
no
that?
manure, no biosolids. We have a no food policy. You know, there's enough guys out there that have been doing manures, and there's a lot of manures running around. We had to differentiate, so we made that decision early on and went with that. But we know that in manures, a lot of times you get into high sodium salts and other issues along that line where we're staying away from the animal waste and the human waste. And so we're avoiding those kind of high sodium salt issues that you can tie up the soil. Yeah.
And pathogens.
Yeah, so we're avoiding that sort of thing.
So your applications, like you guys use it in a field here, would you recommend using it every time during seeding?
Yes.
Or every other year, or just every year?
Yeah,
No,
because you're treating that seed zone, so that seed zone is going to change whenever next year when you plant, you go, as opposed to knocking down 5 tons and doing that entire soil.
And the other thing is that as we move, because we're not seeding in the same furrow every time, the idea is to put, eventually, as you move through your rotations, you actually put a layer of Compell across your entire field, eventually. The other thing, talk a little bit about bulking seed for canola bed.
Okay, Jill started doing this, and we kind of glommed on the idea with canola being a small seed, and you're only running to, and you guys might help me too here, like 5, 10, 15 pounds of seed an acre. And what's that? 3? Yeah. 3. Okay, so you're typically very minimal, and some seeders are very good at handling that kind of low rate, and others are not. And I know that there's some guys out there that have been doing like rice hulls for bulking to get it so you get that mixture and blend. I've also seen where some sulfur products and some other herbicides, even herbicide granules, have been used for bulking. Well, we got on the idea of if you use Compell for bulking, one, it's going to be less than the normal cost of like the sulfur or other things, and then you're also bringing in the biology, the carbon, the nutrients and other things in there right with the seed as you're bulking, so you're getting double the effect, but you still have the performance that you would get out of using those other things in that seed bulking. So So if we were to go out to the plots right now, you would actually see that it's, and I'll let Jill answer that one, but it seems like it's better uniformity,
Yeah.
better singulation out there for the plants. And the stands, you know, I hate to say it looks better, but
It looks better.
How do you guys
she
mix
can
it?
say it.
You don't, okay, this is the beauty of this, is that, you saw those pellets? We actually have mixed it in the tank with the seed because we have a box drill. But if you have a divided tank, and like we do on the big drill, we put it in one half of the box. We put the royal organics in one half and the seed in the other, and then we seed them together.
Then you get variable rate
Yeah.
or your mix or seed, whichever more or less.
Yeah.
And that means that when you get to the knolls, you could increase your rate. So you're putting more carbon, you have more water holding capacity on your knolls, and then drop down to the normal rate when you're in the, when you're not on the knolls or when you're coming down. The other thing about this product is the one thing that Fred and I, when we went and saw Thad and checked it the first time, was that, and Melvin knows this too, we didn't want something that was dusty. And that when you were handling it, you just, you were like covered from head to toe. And then if you got any kind of moisture at all, the whole thing just conglomerated and you ended up with this big mess that you were trying to dig out and whatnot. And the pellets really have solved that problem for us. And that's what we like about this too, is that now we have pellets. For you as a farmer, it's pretty easy to do. I mean, this is my standard practice now. So standard practice is Agzyme in with my fertilizer. Micronutrients, I have various micronutrients, and I will probably broadcast sulfur, elemental sulfur before, and Compell, and we seed everything with Compell. Well, if Melvin has done our seeding with on the faba beans and you ran it, so just let us know what you thought, because you're the farmer.
Well, that's the main thing. It's a little moisture and it still has the micros and everything in it, and it flows good. But before it's too high of moisture and it would bridge or whatever in our machines, but it's low moisture content flows very well now. So.
The first time we broadcast it on with the first trials we ever had, we did the broadcast and we had 2 tons of material on there, and the 2 tons was not as good as the 40 pounds seeded that we put in with the drill.
Placement.
Yeah, it's all about the placement. So, and then in terms of the canola survivability, we did use it to bulk, and we had our mini prills of Tiger Sol 90s. We had Tiger 90 mini prills. We had 15 pounds of that, and then I had the 40 pounds of raw organics in there as well per acre. And one thing that Brian Caldbeck from Revisto Seed said, and Brian is well recognized as one of the experts on canola. He said I had much better singulation in the Royal Organic plots than I had in the other ones, and I had better survivability because of it. And you could really see the difference, and the data showed it too. I had probably, I had 30% fewer plants in the Royal Organic plots, and I had more survivability because I had them singulated. And we expect to have higher yield, and it looks like we'll probably have higher yield there too because of it. So it's just a nice way, like we didn't have a really good air drill that we could do this, so then to bulk all the seed and then still have the carbon. The other thing when we started was that I told Thad, this is like a sponge. I want a sponge with my seed. So I want all the water to be around my seed, so that when it starts drying out everywhere else, my seed is going to germinate, especially those small seeds. And then we
Let's
see.
talk about surface area. When you have carbon, a carbon source for surface area to hold water,
Right.
it's adhesion, and that you just dramatically, because typically our western soils are
Right.
very low CEC, very low organic matter. They don't hold very much water compared to heavier soils, and germination is a pain
As a
in the butt.
problem.
Yeah, especially in the early fall or late
Right.
spring, we have a heck of a time. And then when we get to irrigate it, it's even worse because then if you irrigate, you trust. And
Yeah.
now, if you can hold water, then what is it?
Is
Carbon
it-
holds like
is
20
it-
times what?
20 times, 20,
It's-
30 times.
Water versus
Yeah.
our.
And we actually did a water
big
holding
deal.
capacity on this product, and we're up over 87% water holding capacity.
So the nutrient exchange though. Then
And
you
the-
also
and-
have the CEC, which is
And we also have the
really
CEC.
big for new seedlings because we can't get, if we take MAP or whatever
Right.
and put our ammonium sulfate, where we put right there, that's not exactly plant friendly yet.
Yeah.
It really hasn't mineralized to the form that the
Right.
crop wants. Yet carbon is a great buffer
Right.
and hosts the biology that
Right.
mineralizes it, so you're actually getting that.
Yeah. No, I mean,
what do you
that's
call it,
why,
side benefit.
and that was the whole idea behind this. When Fred and I went to Thad and Chuck, we said, we really want to use compost. These are the reasons we want to use it, but you need to find a way for us to actually use it.
Right.
And they did. And so I think now, folks, we can actually go out and have a look at these plots and see what they look like, because we were waiting for the second front to go. John there is going to have a look at his farm.